Dalton's law, Graham's law of diffusion. Definition and application level questions. Dalton's law of partial pressure. At a constant temperature, the total pressure exerted by a mixture of two or more non reacting gases enclosed in a definite volume is equal to the sum of individual partial pressures of the gases present in the mixture. This is the definition or the law. Now, the mathematical expression. This pressure means it is by the formula PV is equal to nRT. You have to find out. If P1, P2 and P3 are the individual partial pressures of the non-reacting gases enclosed in a volume V at a temperature T, and P is the total pressure. If P represents the total pressure of the mixture, then according to Dalton's law, P is equal to P1 plus P2 plus P3 at constant temperature and volume. Individual pressures are calculated using the formula PV is equal to nRT, and the pressure is equal to nRT by V, where this n represents the number of moles. The number of moles normally calculated by mass of the substance divided by molecular mass. These are the calculations to be used for solving the problem, and assignment is given here. Therefore, please do it and send the answers. Next is Graham's law of diffusion. The law can be stated as follows. At constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. If R represents the rate of diffusion and D represents the density, mathematical expression is R is inversely proportional to root or square root of D at constant temperature and pressure. Let this be equation number 1. We are going to derive the mathematical expression so that you can solve the assignments very easily. If R1 and R2 are the rate of diffusions of two gases at the same temperature and pressure, and D1 and D2 respectively their densities, then R1 is inversely proportional to D1, square root of D1, equation number 2. R2 is inversely proportional to the square root of D2. Combining the equation 1, 2 and 3, R1 by R2 is equal to root of D2 by D1. That is equation number 4. These equations you have to use for solving the problems. Since the molecular mass of a gas is twice its vapor density, that is molecular mass is equal to 2 into vapor density, that means you studied that relationship. Therefore, R1 by R2 is equal to root of D1 by D2 by D1 is equal to also root of M2 by M1, where M1 and M2 are respectively the molecular masses of the two gases under consideration. Therefore, Graham's law can also be stated as follows. At constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its molecular mass. That is another definition. The rate of diffusion of a gas can be defined as the ratio of the volume of the gas diffused to the time taken in diffusion. Using this definition also we can derive another equation which is very helpful to determine the rate of diffusion. That where V is the volume of the gas diffused and T is the time taken for diffusion. If V1 and V2 are the volume of two gases which undergo diffusion in time T1 and T2 respectively, by using the equation 1, we can write R1 is equal to V1 by T1, equation number 2. R2 is equal to V2 by T2, equation number 3. Combining the equation number 2 and 3, we can write R1 by R2 is equal to V1 by T1 by V2 by T2, which is also, we derived that other two equation, you can equate it, which is equal to root of D2 by D1, which is also equal to root of M2 by M1. If V1 is equal to V2, we are putting condition, and if T1 is equal to T2, under this condition we can modify the equation. R1 by R2 is equal to T1 by T2 is equal to root of D2 by D1, which is also equal to root of M2 by M1. If it is T1 is equal to T2, R1 by R2 is equal to V1 by V2 is equal to root of D2 by D1 is equal to root of M2 by M1. All these equations are used for solving the assignments. An assignment is given here. Please try to do it and send the answer.